Now let's look at physics. And from the physics point of view, I'm going to make a model. And the model is going to be mechanical. And the model is going to be based on that picture of the plot of all the points. So I will, let me stick with only 4 points, just to avoid making the picture overcomplicated. And what I will do is, I will try to find a line on this plane that fits these points the best way. Now, how do you do that? Well, the mechanical way would be to make a straight rod, metal rod that never bends, and then try to bring it close to this point and close to that point and close to that, close to every single point without bending, right? How do you bring that rod close to this point? Well, mechanically you can put a spring so that it pulls the rod toward that point. And for simplicity, I would like the spring to be vertical. So you think about the spring here and the spring there, and all these springs are stretched. And all these springs are pulling the rod toward the corresponding points. And then I let it go. And then, of course, it is quite possible that those forces will turn the rod a little bit, and that means that the point of contact of the spring will not be vertical anymore. So there is some mechanical adjustment I can make. I can put a sleeve on the rod so that the rod goes freely through that sleeve, and I pull actually that sleeve so that the spring remains vertical all the time, and that spring remains vertical all the time. And the reason for that is I'm afraid of all those springs being not vertical, and introducing some angles. I'll have to deal with angles. They don't want to. So, even if the springs are all vertical, and I make them vertical, I still hope that all the springs pulling the rod will make the rod stabilize at some point. So the rod will stop moving after some time. And of course, at this point, you either think about this plane being horizontal so that the gravity doesn't pull rods extra to the extra down, or you think of rods having no weight, so that gravity is not affecting the picture. The only important thing is how these springs are pulling the rod toward the points. And of course, these are fixed points. Think of nails there. One end of spring is fixed, the other is moving. All right. So are we clear about the system? Do we expect it to stop at some equilibrium so that the rod is hopefully the closest way to all the points? All right. Well, then, how do you describe the equilibrium in physics? This is going to be equilibrium of that rod. When is it that an object, a solid object, is not moving in physics? Although the forces are acting, right? So there are forces, let's say F1 and F2 and F3 and Fn. There are n forces acting on the rod.
Net force equals 0.
But the net force is equal to 0. When the sum of all the forces is equal to 0. So the equilibrium condition is when the sum of all the forces is equal to 0. Is that it? All right. Okay. You might prefer physics better, but you have to be careful, understanding that whether this is the condition or there is something else to say. Would this condition guarantee that the rod will not move at all?
What about the moments?
The moments. Didn't we forget about the moments?
And some of the moments ought to be 0 as well.
Don't we want the moments to be 0? Oh, look, you can have a rod and you can have one force acting this way, another acting that way, so that the sum of the forces, sum of these vectors is 0. But you won't expect the rod to be in equilibrium, right? It will rotate. So what makes it rotate is the momentum. So what's the momentum?
It's the rotation. Time is still.
So the beauty of momentum is that it doesn't really matter which point you fix and look at momentum with respect to that point. So I will fix this point and I will look at momentum of each force with respect to that point. So the sum of all the way to n momentum of Fi with respect to that point, I don't know, P, let's call it P, will be 0. Okay, that's the second condition. Is that a complete list? Well, of course we need both to be satisfied simultaneously. Is that a complete list of conditions? Will you guarantee that if the net force is 0 and the net momentum is 0, the solid object is in equilibrium? Is that what physics says?